Alright, welcome back to class. We have a very important course as part of your courses that you'll be writing for your chemistry JAMB question. So, we're looking at position theory. Now, the position theory is the theory that explains that whenever there's a reaction, okay, you need specimen A and B. For that reaction to happen, alright, there must be a collision between all these particles, alright? And this particle must collide with a particular amount of energy, alright? Are you getting it now? The minimum amount of energy required for this particle to collide and lead into a chemical reaction is what we call activation energy, alright? So activation energy is the minimum energy required for any chemical reaction to occur. Alright? Remember, I said for chemical reaction to occur, the particles must what? Collide with one another. Are you getting me? And this collision leads to what? Chemical reaction. Does it mean that every collision leads to chemical reaction? No. There are some collisions that will not result in chemical reaction. But any reaction or collision that leads to chemical reaction is called effective collision. What do I call it? Effective what? Collision. So what is effective collision? Effective collision is the collision that will result in bond breaking. Chemicals are always in their own original bond before they form another new compound. Right? So for this reaction to fully occur, that bond for their original combination must be broken, then a new bond must be formed. Are you getting me? So we have what we call bond formation energy and bond breaking energy. Are you getting me now? So the energy barrier that must be overcome for a chemical reaction to occur is what we call activation energy. Take note. Energy barrier. Activation energy is also known as what? Energy barrier. So activation energy is also known as what? Energy barrier. Let me put it this way. Energy what? Energy barrier. So the energy barrier that must be overcome for chemical reaction to occur is known as activation energy. Now let's move away from that. Now, as this reaction occurs, are you getting me now? Are you getting me now? There are two forms this reaction can happen. Are you getting me now? So the reaction could be in the form of after reacting, the original energy will drop. Or after reacting, the energy will increase. So that is those two types of chemical reaction. I want to get that now. The next kind of reaction is what? Endothermic reaction. So what is an endothermic reaction? Endothermic reaction is the reaction where the energy of the reactant after reaction drops. Are you getting me now? This is the energy of the reactant, but now look at the energy of the product here. Alright, this is the initial energy content of the system, and this is the final energy content of the system. So this place is what? Reactant, and this is what? Product. Okay? So the energy from here to this point, alright? From this point where the energy is now, to this point, that is all activation energy. The activation energy we have defined to explain this. The energy barrier that must be overcome for the reaction to occur. Are you getting me now? So the difference between this product and the reactant is called enthalpy change. Are you getting me? Enthalpy change, H. Enthalpy change is what? The difference between what? Energy product and energy of what? Reactant. That's why it is. Enthalpy change is what? Energy of what? Product. Enthalpy of product minus enthalpy of what? Reactant. So what is the meaning of enthalpy? That's what I want to write here now. Enthalpy is energy content of the chemical system. Energy of reaction. Enthalpy is what? Energy content of the chemical system. Alright? So this is reaction pathway. Are you with me now? So this is for a reaction that will release energy. The energy was something higher. But after the reaction, things drop. So energy has been lost in the environment. In other words, we call it exothermic reaction. Exo what? So this is exo what? Exothermic what? Reaction. Now, by the time you do this calculation, you discover that it's going to be minus. Are you getting it? Why would it be minus? Because product is lower than the reactant. So product minus reactant will give a negative value. So enthalpy change for exothermic reaction are always negative. Are you getting me now? This is for exothermic reaction. So let's look at examples of reactions that are exothermic. Reactions that are what? Exothermic. So number one, the very first one is combustion. Very first one is what? Combustion. So when anything is burning, what will happen? It releases heat to the environment. It releases what? Energy to the environment. So combustion is what? An example. Another example is what? Roasting. What I say? Roasting is an example of exothermic reaction. Alright? Another example is what? When you have thermal decomposition. So let's use thermal decomposition of limestone. Let's use limestone. Thermal decomposition of limestone. Are you getting it? That is what? Exothermic. Do we have other exothermic reactions? Yes. Imagine you dissolving your sodium hydroxide in water. What happens? You will see the warmth around it, right? So the solution of sodium hydroxide is right? The solution of sodium hydroxide. Are you getting it? Now also, when you try to dilute H2SO4, it releases heat in the environment. Remember, we don't pour water inside acid. We pour what? Acid inside water. So as the dissolving it, it touches the environment, it releases it. So it's an example of what? Exothermic what? Reaction. So we have what? The solution of what? The solution of what? H2SO4. H2 what? SO4. Remember, H2SO4 is also known as what? King of chemicals. Are you getting it? Yes, king of chemicals. Once we dissolve H2SO4, we are releasing heat to the environment. Can you see how many examples we have? 1, 2, 3, 4, 5. There are many more examples. Are you getting it now? Let me put another one more important one. Neutralization. What I call it? Neutralization. What is neutralization? Neutralization is actually the reaction between hydrogen ion and hydrogen ion. Hydrogen ion is coming from an acid, hydrogen ion is coming from what? Base. So when they mix together, what will happen? They will form water. Are you getting me now? So in other words, neutralization is the reaction between acid and base. That's just simple definition. So neutralization is an example. Are you getting me now? Look at the energy profile diagram of what? Exothermic reaction. Can you see that now? Are you getting me now? Okay, let's take